Good afternoon, dear students. On our previous lesson, we were working with determinants, calculated them for the second, third, and the fourth order. And our today lesson will be about matrices. Currently, you already have a presentation on DL, and so if you found the link of video recording, so you have the recording as well. What do you remember about matrices? What is the matrix, actually? Who can go first? Who wants to be the first? By the way, do you hear me or not? Some issues with my connection. The question was, what do you know about matrices? So, what is the matrix? What do you remember from lectures and our previous lesson? Okay, so who is the first? As I see the queue, Matvey.
The matrix is defined as an ordered rectangular table of numbers. There are some types of matrices, such as zero matrix, when it equals to zero, identity matrix, just one, row vector is when we have only one row, and column vector when we have only one column.
Okay, just to correct you, actually, the matrix shouldn't always be ordered. So, what actually do you mean that ordered? So, sorted or what?
Maybe yes, sorted, like it can be an array or table.
No, actually, that's just a table of numbers. Yeah, and as you said, it can be a vector, so a row vector, column vector, so one of the dimensions can be one, and one by one is just a number. Okay, and what about identity matrix? I didn't correctly understood the answer. So you mean that one, but how it actually does look like?
It's a table with when we have a diagonal of just one diagonal of number of now one numbers one, and others are zero.
Yeah, so actually, the important thing that identity matrix only square and it have only ones on the main diagonal. So correct. Okay. The next question: which arithmetic operations we can do with the matrices? Sophia?
You mean addition, subtraction, multiplication?
Correct.
Those.
So how do we do these actions? How do we add, subtract, and so
on? We can add and subtract only those matrices if that have dimensions that are the same for them both.
Correct.
And about multiplication, we can multiplicate matrix by the number. It means that each element should be multiplied by the number.
Yeah, actually, we can multiply matrix by the number, but
And by the
also,
other metrics.
yeah, but what so what is the rule of matrices multiplication? So can we multiply all matrices or not?
We can't multiply matrices that have different numbers of rows and columns. I mean, one matrix should have the same number of rows as the other matrix should have the same number of columns. I'm sorry, it's hard to
Yeah,
explain.
actually, you think on the correct way. So let's write it. A little bit laggy paint. So we have matrix A with such dimensions n1 by m1, and matrix B that has dimensions n2. Okay, just believe that it's 2. N2 by n2. And these matrices can be multiplied only when m1 is equal to n1. So yeah, that's correct. So number of columns of matrix A must match number of rows of matrix B. So what in general what does it mean? So if we can multiply matrix A by B, so A on the right and left on the and B A on the left and B on the right, it doesn't mean that it equals so that we can commutate them to swap their places, and even we can't be sure that it's possible, because if n1 does not equal m2, we can't do it. But sometimes we have some matrices that are commutative, so we can change their order, and the result will be the same. Okay. What else can we do with matrices? Who wants to answer? Vadim?
Yeah, we can transform the matrices and multiplicate, for example, rows or columns and add to another rows or columns.
Yeah, that's important operation. We will use it today and on the next lessons. Yeah. By the way, we were doing such things when calculated determinant of the fourth order, so it helped us to calculate easily. Okay, and what else? Bogdan?
We can find the inverse of matrix.
Hmm.
And in order to do that, we should take the transpose matrix. We should find the transpose matrix, and then for that matrix, find cofactors, and our cofactors will be the elements. We should also find the determinant of the matrix, and then write a fraction of 1 divided by determinant of the matrix, and then we take all our cofactors and put them in the rows and columns of new matrix, and that will be our inverse matrix. But we should also check the condition that that our base matrix times inverse matrix is equals to identity matrix. I think.
Yeah, so we need to verify that their multiplication, by the way, they're commutative also, so we can can multiply them from different sides. Yeah, and their composition will equal to identity matrix. And no, so therefore we can inverse only a square matrix. But actually,
Yeah.
not every square matrix can be inversed. So if a zero matrix has no inverse matrix because the determinant is zero, so the determinant mustn't be equal to zero. And actually, you described only one way of matrix inversion. We will try another one today. Okay, and you said something about transposing matrix. So what does it mean actually? Who can answer? Who wants? Valeria?
It means we should swap rows with columns.
Correct. And also the question, can we transpose only a square matrix or any?
Only square.
Sorry? Only square? Are you sure?
No.
No. Okay. Actually, if we transpose matrix n by m, so we will have just matrix with inverse dimensions. So we can transpose any matrix. Actually, it's the typical mistake of beginners, so be attentive. So we can transpose any. We can transpose a vector column and it will be a vector row and vice versa. Okay, so let's do our favorite part, exercises. And the first is quite simple. We will add matrices, subtract them. So the first question actually, if all matrices can be added or not. Who wants to answer? Dmitro?
Only matrices with the same dimensions can be added, or
Yeah, so, and which can we add, which cannot? Dmitro, go on. So continue your answer.
yeah, the ones with the same dimensions, so A and C, for example, here.
Yeah, so actually we can add A, C, and D, but we cannot add B to any of them. Correct. And now let's calculate A plus C. So yeah, let's do it individually and then compare the result. Actually, it will be so simple. And then we will calculate part B together. If you are ready, just raise your hand. Pavlo?
It will be matrix with first row 0, 4,
Mhm.
a second row 8, 7, a third row -1, 7.
Correct. Okay, and let's do the second exercise together. This annoying panel. Okay. Dmitro, do you want to answer, or you have some questions?
Answer?
Well,
I
actually,
didn't do it yet, but-
maybe some of you need more time, so let's do it together. So let's calculate C. Calculate part B. We will write in details. Well, actually, this exercise is quite simple, so can we will skip multiplication and then adding, and we will write like in one matrix. So 2 by 2 minus 3 by minus 2. Don't choose the minus, and plus 3. So that's the first element. And then it's 2 by 1 minus 3 by 3 plus 5. Here 2 by 3 minus 3 by 5 minus 1. And here 2 by minus 1 minus 3 by 8 plus 2. We'll skip 0 actually. Okay, well, let's leave it for now. Minus 3 by minus 1 plus 1. And the last element, 2 by 4 minus 3 by 3 and minus 4. Okay, and what is the result? Let's calculate together. Okay, who is the new person maybe? Matvi, Sophia, Pavlo. Okay, who hasn't answered yet? Andrei?
The first element is 13.
Mm-hmm. Yeah.
1
1. Oh, stop.
minus 10
Stop. Here is 2 plus 5 minus 9, so minus 2. Yeah, incorrect. And here,
minus 10
minus 10.
minus 24
Yeah, and here
4.
4, and here
-5.
-5. Okay, and let's check our result. So everything is correct. Nice job. And now let's multiply matrices. Firstly, calculate. Let's first multiply A by C, and then we'll. Okay, AB will be your homework. So what is the first question? What will be dimension of A multiplied by C? Valeria?
2 by 1, because we have 2 rows in the matrix A and 1 column in
Correct.
C.
Correct. Okay, so now let's calculate it together. I will erase everything. Okay, I can't do it, so we'll just create a new one. A little bit. Oh, not so straight, but okay. So now what do we have in this cell? Let's calculate it in details for now, for better understanding. Who can assist me? Who will be the new person? German?
We should take the first row of matrix A and multiply it by the column of matrix B. This will
And-
be the first element, and the second element will be the second row of matrix A.
Okay. And now let's do it in detail.
We take every element of the first row and multiply it by every element of the second column of the column of second matrix and add them.
Yeah, so let's do it together. So what we write here now, just in details.
1 by 1 plus 0 by 2 plus minus 2 by 3.
Correct. And
3 by 1 plus 9 by 2 plus minus 5 by 3.
Yeah, correct. And now just we will calculate it by the end. So here is 0, 1 minus 6 is -5, 3 plus 22, so 25, 25 minus 15 is 10. And let's check. 6. Okay, let's recalculate. 3 plus 18. Plus 18. My bad. 3 plus 18 is 21. And 21 minus 15 is 6. Yeah. So let's calculate attentively. Okay, let's calculate it. Let's calculate A by B as well, because we have enough time for that. And by the way, what will be the dimension of composition of A and B?
Two by three.
Correct. By the way, do you know about vector scalar multiplication? Maybe did you have it in lectures already or not? So actually, it's so we do analogically, but of course we will talk about it on practices later. Let's move to the next line. Okay, so what do we write here? In details, who will assist me? Who? Katerina, if I'm not mistaken, you are the new person. Okay, so go on.
1 by minus 1 multiply, then 1 by 0 by 5 plus 0 by 5 minus 2 by 0. The second row is 3 by minus 1, then plus 9 by 5 minus 5 by 0. The second column is 1 by 2 plus 0 by 6 minus 2 by 3. The second row is 3 by minus 1. Wait, sorry. 3 by 2, 9 by 6, and minus 5 by 3. The third column is minus 2 by 4, minus 2.
Stop. Yes, not correct. Yeah.
Sorry, 1
Don't
by
be
4.
afraid.
Yeah,
Yeah, 1 by
1 by 4 plus 0 by 7 and minus 2 by minus 1. So the second row is 3 by 4 plus 9 by 7 and minus 5 by minus 1.
Okay, and now the most interesting part. So now
Calculating?
yeah, calculating. Okay, so minus 1 minus 2 is minus 3. But I would be grateful if you help me as well.
I can help.
Yeah, it would be nice. So what we have here?
The second row, minus
Okay, let's go
3
with the second row.
plus minus 3 plus 40 and
Plus 40, are you sure?
45.
Yeah. Yeah, so
42.
Yeah, 42. Yeah.
2 plus 0 minus 6, it's minus 4. 6 plus 54 minus 15.
Mhm.
Wait. Mhm. 45.
Correct.
The third column is 4 plus 0 minus plus 2. 4 plus 2, 6.
Correct.
12 plus 63 plus 5.
And it's 80.
18.
Okay, and now let's verify it. So something is not correct. So -1 plus 0. Okay, so by the way, it's for everyone. If you see that something is not going correct, don't be shy to correct us. So a little bit lost. I lost my attention as well, but the rest is correct. Okay. So actually, what now I just will ask you how to solve the example 3. If we have some time at the end of the lesson, we will do it. But actually, analogical things. But so who can answer how to solve? Oh, spoiler. Who will be a volunteer? I want to hear someone new. If I'm not mistaken, okay, Bogdan.
We can place our matrix A in place of X. So like,
Yeah.
and for instance, it is going to be 2 multiplied by matrix A multiplied by matrix A plus 3 multiplied by matrix A minus 5.
But -5 and minus. How can we subtract matrix here? Oh, how can we subtract a number from the matrix? That's a question. Interesting question. So how will we behave in this way? What does it actually mean? So Bogdan, any ideas?
I don't have any idea.
Sorry? No idea.
I don't have any idea.
Okay. If I'm not mistaken, David wanted to answer some time ago. So it's your time now.
So I think we should use these coefficients of x in the matrix somehow.
So I'm asking about -5. So what will be placed here? So how can we subtract a number from the whole matrix? Yeah, that's an interesting question. Any ideas?
Maybe we have to use identity matrix.
Correct. Yeah, we multiply by identity matrix. And here is the example. So we just multiply -5 by e. So you will do it in your own at home. Maybe we will calculate it today if we have some time, but we have more important material. So, by the way, I have a question. What is the rank of the matrix? Who wants to ask? Who wants to answer? You know, I want to hear new people. I want to hear everyone. So, who will be new? Maybe Volodymyr. Not. Are you here on with us? By the way, if I'm not mistaken, maybe Vadim, you haven't answered yet. So, okay.
I answered, but I had a small answer in
Oh.
such of the lesson here.
Okay, so
How we find a rank? It's the biggest minor which is not null. I can't remember.
yeah, so actually non-zero as the biggest minor that is non-zero. And here we have matrix with dimensions 3 by 4. And what actually can be the maximum possible rank of this matrix?
Four maybe.
Can we calculate minor of
Force, not
are
if
you
you're using
sure?
we
But-
can, but we need to delete the zero row column.
No, so we have matrix dimensions 3 by 4. So how can we achieve, how can we have rank of the 4 here? How can we calculate a minor? So the minor is actually the determinant. So the determinant of the fourth order. Can we do it here?
No.
No, so
you need to operate and have a 3 determinant.
So actually, yeah, the maximum possible rank is 3. So the maximum possible rank is the least dimension of the matrix. Okay, so now we are going just so like we're going to check minors of each order for now. So starting from the minor of the first order. So this is a non-zero matrix. There are some elements that not equal 0. So for example, this one. So the rank is greater or equals than 1. Okay, let's check the second. So if the matrix can have the second rank, which minor do you want to choose? Which of them? So someone new. Who wants? Okay, Pavlo, I haven't heard you for ages, and you want to answer? Yeah. So which do you want to choose?
Maybe a third column and first row and second.
So minor of the second order. So okay, but let's write for, just the rank of A is greater or equal than 1. And now, so which minor do you want to take? Which do you think won't be equal to 0? So just you can dictate some numbers. So I just didn't understand. I haven't understood your answer. So could you repeat, please? What did you mean? This one, right? Or another one, maybe? By the way, do you hear me or not?
Yeah.
Yep.
Yeah.
Yeah, so
Excuse me, I have a question.
yeah.
When we had a lecture, in the example we had, like a first order is how we have 1 in the beginning, and the second order is like 3, 0, 0. We can for the second order we can take any numbers we have.
It will be, we will discuss it later, but we can select any minor of this matrix. So, we just use the definition of the rank of the matrix. So, but it was a good question. Okay, so now for now let's just go with this minor. By the way, Vadim, do you have a question or you want to answer?
I want to answer.
Okay, so
On the matrix question, if you take 1, the second order will be 1, 0, 3, 0,
mhm.
and it will be 0.
Yeah,
So we take, for example, like first 2, and the next one of the second order will be 2 minus 1, 1, 2, and it's not equal to 0.
yeah, it's not equal to 0. It will equal 5. That is not equal to 0. So the rank of matrix A greater or equals 2. And now we actually can take, so for the third order, we can take minor, so this one or this one, and actually which important property of the determinant do you remember? So if all elements in the row or in the column are zeros, okay, who else? Maybe some new people who remembers such property. So new of you, maybe Volodymyr or Ivan, Lilia, Alexander. By the way, Sklero, what is your name? It's interesting.
I couldn't sign up, Vitaly. Yeah.
Vitaly, okay, so you have some problems with sign in. Oh, okay, so Vitaly, so do you remember such property if we have all zeros in the column or all zeros of the row of the determinant? So what it will be equal to? No idea, as I understand. Okay, so Dmitro?
It will be equal to 0.
Yeah, it will be equal to 0. So actually, all minors of matrix A are equal of the third order are equal to 0. So its rank equals 2. And now I will clear it. And actually, yeah. So there was a question about continuing with other minors. So now we will use the method of bordering minor. So we select any minor we want, firstly. So now we select minor of the second order because the first order it's obvious. So now we will look this example. Where's my drawing? So just a moment, I need to hide everything that I don't need. So in this example, we see this minor, and so we calculate it firstly, and it equals so -4 plus 6, it equals 2, and it's not equal to 0. So then we conclude that rank of matrix A is greater or equals than 2. And now we, when using a border minor method, we can select a minor that is near to this one. So either this or this. Actually, in the example, we have this minor. So now let's clear it. It's already actually, yeah. So let's calculate it. This minor that is selected here. So, so mine 4 plus 3. So here is 0. 0 minus 2 and minus 4. So it equals 1 and it's not equal to 0. So the rank of A is greater or equals 3. But so the maximum possible rank, what we would be equal to?
3.
The maximum possible for this matrix.
4.
Yeah. So 4 is the maximum. And now we choose this border minor. If it's not 0, so that it would mean that it equals 4. But now we won't calculate this determinant because it we will have to spend some time for that. But we need to do other tasks. So now we will just believe that this minor is equal to 0. So this one, actually. And we can use this minor as well. So border it also. So either this minor or this. So it must contain this minor of the second order. So both of them are equal to 0. It means that the rank of matrix A is 2. Or is 3. Sorry. And now, do you have any questions or not about this material?
No questions.
Okay, no questions for now, and we need some time to have a rest, so have a break for 5 minutes, and we will continue on calculating ranks with using some methods that you already know, and also we will find inverse matrix. And now have a rest. Okay, let's continue. And now we will use the method of elementary row operations to find the rank of matrix A. So it's one more way to do it. And now let's start. I will just do like that. And we'll clear it. Just to save our time. So our job now is to transform matrix A, so not to triangular view because not to triangular form because it's not square matrix, but to trapezoid view. So that here we will have zeros here, here, and maybe here. So actually, these elements will equal to zeros. And now, what we will do, we can use either this sign, tilde, or maybe like just an arrow, because such matrix is not will not be equal. So I start with the first row. It won't change. And here we will leave only zeros. Why zeros? Because here I will here I'm taking this row, I multiply it by 5 and subtract from this row. This row, so for this row, the third, the first row will be multiplied by 4 and subtracted from the third row. About the fourth row analogically. So here we multiply 5 by -1. But by the way, let's do it together. Who wants to be a volunteer? So some new people who hasn't answered yet. Alexandra, if I'm not mistaken, you haven't. Alexandra, are you with us? Okay, just raise your hands. Who wants? Or maybe you don't hear me, or I don't understand.
We're here, we just
We
don't
here.
really understand what to do.
So if you have some questions, so don't be shy to ask, feel free. So
We multiply first row on 5 on
by
-5
-5, yeah, and add to
and
this.
So
like so you remember doing it for determinants of the fourth order. So actually the same operator.
I can do this.
Yeah, so go on.
-5 multiply -1, it will be 5. Ой, минус. Нет, сейчас.
So we
Да,
need also add to here.
plus. Сейчас. It will be 6.
6, right?
-5 multiply 2. It will be -10 plus 7. It will be -3. -13.
Yeah, -13. Here.
-19.
-19. Correct. Okay, this row.
5
Mm-hmm. This
minus 7
minus 7. Okay, so and here
minus 11
minus 11 and
minus 15.
minus 15. Okay. And here
Or 11
11, yeah.
minus 10
Minus 10, yeah.
minus 24
Minus 24. Mm-hmm.
minus 34.
Minus 34. Okay, correct. So, and now we need to get zeros here. Actually, we won't achieve them for the first time, but so now we'll go and simplify it. So the first row is without changes. So I can do like that, by the way. So let's not so let's just copy and paste, and it will be more readable than we have. So here we have zeros. And actually, what do you suggest to do now? So firstly, a little bit to simplify it, and then go on. So, who wants to be the next? Alexandra, if you are here, you can continue. By the way, who was answering before? Forgot it a little bit. So,
Pablo.
Pavlo, okay, so and who will be the next? Just raise your hand.
We need take 0 in third row and second column.
Third
Yes.
row? Mhm.
No, third and fourth row and second column. Yes.
So yeah, actually, I suggested firstly to take this row and subtract from this, and subtract from this multiplied by 2. Actually, what is the idea? So now let's leave it without any changes. So 5 minus 7 minus 11 minus 15. Well, actually, let's copy and paste this row, which is by handwriting, because we have not enough space in such case. Okay, and what we will have here? So we just subtract. Sophia, yeah, go on.
Am I right? We multiplied the third row by the -1 or what?
We just so now we leave this row without changes.
So we can multiply it by -1, and then plus the second row.
Yeah.
And it will be 1, then 4,
Mm-hmm.
-2,
Correct.
and -4.
Mm-hmm. And for this line, this row,
For this one, we can maybe multiply the second row by -1 and then plus the fourth row, and
I suggest to take this line, multiply by -2, and then subtract it from this. And you will see something interesting.
So we'll multiply by -2,
Yeah.
and it will be 1,
Mm-hmm.
then 4,
Mm-hmm.
2, -2.
-2, yeah, it's important, don't lose the sign. Yeah, and here,
-4.
-4. Okay, so do you see something interesting here or not?
The second line have the same numbers as in the
Yeah, so
fourth line.
the same coefficients. And what does it mean actually?
Oh, I don't remember.
It will be 0.
Yeah, so we just eliminate this row because we have the same coefficients. So why it's such a good example? For now, I just do this. And do this actually. And then, yeah, here I write 0, 0. The last row will consist of zeros. Then let's write the second row without any changes, and now we have to set 0 here. So we need to eliminate this 5 with the same way. So who will assist me now? Just raise your hand. Who wants to be a volunteer? Valeria, yeah. Go on.
Okay, you can multiply the second row by -5
Mm-hmm.
and add to the third row. So it will be 0, 0. On the third place, it will be -27.
Mm-hmm.
Then -2 by -5, -1,
Mm-hmm.
and 5.
And 5, correct. So we have matrix in of this form. So actually, so what can it's a question for you. What can be the maximum rank here?
The maximum rank is the number of non-zero rows, so it will
Yeah,
be
no.
3.
So maximum is can be 3. And now, which minor do you want to calculate to verify it? So which will you choose? Which of them? Which looks more attractive, easier, the easiest way to calculate?
the first three columns, right?
Yeah, actually this
Mm.
minor. And how to calculate it? We just multiply the main diagonal, because we have zeros here, and it will equal to 27 minus 27 and not equal to zeros. And it means that rank of matrix A equals 3. So, any questions about this task or not?
No, I don't think so.
Okay, so if no questions, we will go on. Actually, we will do such operations, elementary transforms,
I
a
have a
lot of
question.
times. Yeah, go on.
How can you know like which operation you should apply to the matrix?
So do you mean
Like
the method?
to achieve, yeah, by this method, like, yeah.
Well,
What if like it doesn't come in your mind like that's yeah.
Well, actually, it depends on the task. We can use any method, so we can just calculate all possible minors. But it's not efficient, really, not efficient way. We can use border minor. It depends on the task, actually. And for this matrix, it would be good to. So it's just a good example to try such method. That we have two the same rows, and we can just eliminate. So did I answer your question or not? By the way, you will use such operations a lot of times when solving systems of linear equation. So on the next lesson, actually. So did I answer your question or not?
Yeah, like kind of, because I ask like when you do like simple operations with the like rows and columns. So for instance, you multiply this row and add it to another column, and how do you know like the sequence? I mean.
Mm-hmm. Actually, I here I see which of them can be, so just a convenience. Here I see that it would be convenient to have one here and have one here. So if we change two lines, so if we swap their places for the matrix, it will be the equivalent matrix. So I could just move 5 here and then subtract from this. So in this way, sequence doesn't mean. But actually, the most convenient way to firstly to set zeros on the second column, then zeros on the so first zeros on the first column, zeros on the second column, then the third column, and so on. Of course, you can start from this side, but is it convenient for you or not? I don't think so. So, have I answered your question?
Yeah, thank you.
Of course, you can try from right to left, but it will break your brain. So just so you are used to read from the left to the right, but not vice versa. That's why we do in such way.
Okay, thank you.
You are welcome. And actually, our example that so the same idea. the solution. You can, so it would be good to check it at home. And now we will use the method of elementary transformations to find the inverse matrix. We will calculate inverse matrix using using cofactors next time, not today. Today we will try another method. We have 15 minutes for it, so I guess that it's enough. And now let's let me just print screen. And now I will explain what we are going to do. So here is our matrix A. We need to find inverse, and we do the following thing. We expand our matrix. We use so we're on the right side. We have identity matrix, and we use elementary transformations. So actually the same thing, and with these elementary transformations, I will here I will transform this matrix to the identity matrix, and the matrix on the right will become and then the inverse matrix. But here for finding inverse matrix, we cannot swap rows. Their order is important. Okay, so let's start. It will be more understandable if we just start doing something. Yeah, now we will have a lot of fractions. It's not convenient, but we have what we have. So I need to get, I need to have here 1. I just divide the first row by 3, the whole this row. 1, 2, 3rd, 1/3, 1/3 here. Here just zeros. Here I need to set zeros to it. I need to achieve zeros. So here the calculation will be not convenient because of fractions, but let's do it. So here we have 0, and we need to multiply this the first row, what we already have, by -4 and subtract from this one. So 5 minus what? Who will assist me in this task? Who wants to take part? Vitaly? Yeah, go on.
Well, I could try.
Yeah. Sure.
So 2/3 is approximately 0.6, right? Well, yeah.
We use regular fractions, rational.
Yeah, I see. So that will mean that 5 would be 15 of thirds.
Mm-hmm.
And that, so yeah, it will be 15 divided by 3. Oh, in thirds, then 2 would be 6.
Actually, it will be 7 of third. So 15 minus 8 because we multiply by
I
4.
see.
Never mind. Okay, and now here what do we have?
Well, two would be. Well, first of all, two would be less 6/3. So then, we'll subtract
Okay, well,
1 to
yeah.
3. All right, got it. And
Yeah, so my bad, 2 of third. So 6 minus
right,
4. Yeah, my bad. Okay, and we don't
and
forget about this matrix as well. So here we have zeros, so just
so
minus,
minus 4/3.
yeah, nothing changes. Nothing changes for now. And here we multiply by -2. So 3 of third minus 4 of third will be -1 1 of third. Take part as well. So verify that everything that I'm doing is correct.
We multiply by -2, or
We multiply by -2. Yeah. So
so that'll be so yeah. and, 10/3 from
yeah, 10/3. Correct. And here
here we just have -2/3.
-2/3. Yeah. Here actually
And -2/3.
just a 0. So
Right.
nothing changes, and here as well. So because we have 0. Okay, and now we need to achieve 1 here and zeros here. So we need to. So here we divide this row by 7 of third. And what we actually have here is 1, of course. Here 2 over 7th. Here -4 of 7th.
One
3
of
of 7th, attentive. And here is 0. And now we will have to calculate missing coefficients. So these fractions, I know you don't like them, me too. So let's calculate it together. So here I need to multiply 1 by 2 of the third. Okay, let's do it accurately.
So it just would be 2 left.
So here is 0, and here we multiply, we have a 1 of third minus -4 of okay, now let's we have no time to calculate everything. Let's just look at the example, because we have not a lot of time, but what actually we have. So let's compare actually the first iteration. So here it is. We have the same coefficients, and the same coefficients here and here. So everything is correct. Then what we also have, so the same here and here, and actually this line. So you understand the idea. We need to eliminate numbers here, so to set zeros, and then you will have to achieve zeros here. And this matrix becomes identity matrix. Let me clear it. And this matrix is identity matrix. And now we can also, for better reading, we can move this fraction out of the matrix, so just out of brackets, and it will be more readable. And then, so we finish it at home. You will have to verify it. So either multiply initial matrix by inverse from the left or from the right. It will be identity matrix as the result. So any questions about it or not?
No questions.
No questions.
No.
Okay, no questions. And now we will just analyze the next. So I will just ask you how to solve this exercise. So this exercise matrix equations. So the first one, how to solve it? You need to find x. By the way, what is x? A matrix or a number?
Sorry, can you repeat the question?
What is x? Is it a matrix or a number?
Matrix.
Yeah, it's a matrix. And how to find it?
Matrix 3, 5, 5, 9 поділити on an last matrix. On the first matrix.
Actually, in the case if we work with numbers, we can divide, but for matrix we cannot. So there is no operations of matrix division. But what actually you can do? The alternative.
You can multiply by the inverse matrix.
Yeah, by the inverse matrix. And from which side? From the left or from the right?
From the left.
From the left, yeah. So how will it look like? This. Multiply by this initial matrix. Okay, let me skip it by this 3, 5, 8, 9. So it will be eliminated. It equals E. So we will have the next. And so you will have to find the inverse matrix of this one and then to multiply. This equation is analogical. So actually any way that you like, find the inverse matrix and then solve. And also you will have to calculate the rank of the matrix. Here are different dimensions. By the way, did you check in on DL? So did you mark yourself as present? I hope
Yes.
so. Okay. So any questions from for me?
No.
Okay, no questions. So now you can start, after this lesson, you can start doing your individual task for matrices. So this exercise 2, and yeah, so for now just exercise 2. But maybe so there are linear equations, so it will be later. So task 2 you can start doing. And of course it will be nice to review these examples, to do exercises that left for later. And now we are finishing, so have a rest before the next lesson if you have. If not, just have a rest, have a nice day. Bye. So goodbye.
Thank you so
Thank you
much.
for your lesson.
Goodbye.
Have a
Have a
good
nice
day.
day.
Thank you for the
Thank you.
lesson.
Goodbye.
Goodbye.
Yeah, stay safe. Thank you for your attention.